Okay, real fast, folks. Let's talk one more time. Some of you had notes from Friday. Some of you did not, but let's talk real fast about today's not the 9th month. It's the 10th month. If you did take notes, how many of you took notes? Okay, let's do this. How many of you did not take notes? Okay. We'll do this. If you already have notes, this might be a lot of the same thing. It could be stuff that you could add into your notes. So, because I'll be honest, I don't remember. I don't even remember what section this is. What section is this? 5-4. May I see the notes that you took? No. Well, okay. So, complex numbers, just to review very fast. I, the letter, the number I, and it's a lowercase I, it's not capital letter I, is not in the set of real numbers. Okay, that's why we got to be able to do something with this. And I reviewed with you how to solve a quadratic equation. We solve quadratic equations one of two ways. If I were to give you x squared minus 25 is equal to 0, you can look at this one of two ways. You can say, hey, it's a quadratic. I know that I can factor it and set each factor equal to 0. Or you could look at this and go, okay, I see I've got perfect squares there, right? Here's a different way that you can add into your notes. Instead of factoring, because it's a difference of squares, and getting x plus 5 and x minus 5, and then setting each factor equal to 0 and solving. You guys remember that? You could also solve this. How? How could you solve that? There's one other way I could solve that equation. Add 25 to both sides. Okay? Which gives you x squared is equal to 25. And then, folks, how do you undo a square? You take the square root of it. So another way to do this problem is to take the square root. And you have to remember, when you take the square root of a number, it actually gives you two answers, plus or minus 5. So we actually get two answers. So this is one way to solve the equation. This is the same, a different way to solve, but we get the same values. You know, solution set of -5 and 5. X is equal to positive and -5. It's the same equation solved two different ways. Okay? Now, if I were to change this around and say, solve this, x plus 25 equals 0. First of all, can you factor x squared plus 25? No, it can't be factored. All right, just make yourself a note. X plus 25 cannot be factored. So the only option for us to do would be to subtract 25 from both sides. And then we get x squared equals -25. Folks, can we take the square root? Before Friday, could we take the square root of a negative number? Before Friday? No, we can't. And before Friday, before you changed your calculators over, when you took the square root of a negative number, it gave you a non-real answer. Is this what it says in the calculator? And then it gives you go to or quit, I think. I think that's what it gives you. Non-real answer. Non-real answer. What's that mean then? Our answer is not in the set of real numbers, correct? So then the video went on Friday and it said, okay, what do we do then? We change our calculator over into a different mode, into the imaginary, that A plus BI mode. And can we solve it then? When you put it in your calculator, folks, what is the square root of negative 25? It's 5i. That's very simple. I'm telling you, the only one I remember. I really don't even remember the pattern of, yeah, I do. Yes, I do too. Let's take this one step farther. So what about that I thing? What's anything to the first power? That thing. So I to the first power is I. I squared. Bells and whistles, stars and rainbows, and unicorns and fairies. I squared is what? -1. And then I have to think, I cubed. And I used to know the pattern back in the day when I first learned about it. But then I thought, why do I have to know the pattern? I don't have to know the pattern of those first four, because I cubed is just I squared times I to the first, is it not? What is I squared, y'all? -1. What's I to the first? I. What's -1 times I? -I. Oh, yeah, there it is. So I really only have to remember I squared. But if you knew the first four, it would be helpful. Pardon me? Because the pattern repeats over and over and over. Every four, it repeats. Okay? Well, watch. Say what? I'll show you. I to the fourth. Well, isn't I to the fourth actually I squared times I squared? Yes or no? All I'm doing is using my rules of exponents, prior knowledge from Algebra 1, and I'm good at the rules of exponents. I know my rules, okay? What is I squared? -1. Oh, I squared is -1. What's -1 times -1? +1. Now do you see the pattern? I, -1, -I1. And if you guys can come up with some clever way for me to remember, because you know I have to have a clever way, then please share. Okay, this is what we have to know. Let's think about it. I to the fifth. Well, I would think I squared, I1. Right? I to the first, not I1. -1, -1, I. What's a negative times a negative? Positive. What's +1 times I? I. Look at there. I. It starts back over. Let's go with I to the sixth. Again, the only one I know is I cubed, or I squared. Folks, what's I squared? -1. What's -1 times -1? +1. What's +1 times -1? -1. I'll be John Brown. Look at what's happening. It's starting through that process again and again, isn't it? What am I going to choose for out of the seventh? I squared, I squared, I squared out of the first, because Miss Perry only knows I squared, right? So what is it? Out of the -1. Holy moly. Well, we've already determined that this is -1. What's -1 times I? -I, I'll be daggone. Look at it. It keeps repeating. We could do this forever and ever and ever, but it's not necessary to do that, right? Anytime. It's very simple. Very, very simple. But you have to know that pattern. We really do need to know the whole pattern for those four. I -1, -I1. I -1, -I1. If you'll look at your negative numbers are in the middle, and then it's it just repeats. I1, I1. Doesn't it? And then throw the negative signs where? In the middle. The ones on the outer shell, if you will, they're positive. They're positive. So think of it that way. Now, we talked about this, or I talked about it. You listened on Friday to the video. If I wanted you to simplify, I'll change this up just a bit. if I wanted you to find the square root of negative 49, you ought to now be able to immediately give me what is an answer? 7i. Does everybody agree with that? How do we know it's 7i? We know it's 7i because if I were to break that down, which I'm not, but if I ask you to, what's the square root of negative 1? I. And what's the square root of 49? 7. Boom. This would be if I told you to prove, if we went back to geometry, and I know how you guys like proofs. If I said prove that the square root of negative 49 is 7i, this is your proof right here. That's your proof. See? Are we ready to roll on? Yeah? What about this one? Excuse me. Something very simple. Simplify that for me. You can just add it into your notes. The square root of negative 32. How would I break down the square root of negative 32? Negative 16 times 2? Could we do that? What is the square root of negative 16? 4i, where does it go? Outside. 2 stays inside, yes? How many of you had 4i root 2? Good. Any questions? Y'all, is this facile or difficile? Facile? Okay. All right, so can we go one step farther? One step farther. What if we were to have 2 root negative 5 times 4 root negative 20. What's the first thing we have to take into account? We got to take care of those negative ones first. Okay, we got to take care of those negative signs underneath the radical. So if I took care of those first, then what would that give us? Where would that leave us? 2i root 5. You guys agree with that? All I did was just take care of the negative 1, move it as an I outside. How am I going to take care of this? I could go ahead and write 4i root 20. I could do that. And now what? Dylan, what you thinking? Okay. What now, y'all? How? Pardon me? I could. I could also do what? What multiplies with each other? Don't the numbers on the outside multiply with the numbers on the outside? Yeah? What's 2i times 4i, folks? 8i squared. And I'm going to write that. I'm not going to skip a step for my notes. And then, what's root 5 times root 20? Root 100. Everybody with me so far? Yeah? Can I simplify that? Yeah? What are you going to simplify first? Take out the 10? We can do that. Take out the 10 because the square root of 100 is 10. So 8i squared times 10. What else can I do? Multiply what? 8i squared times 10 is what, y'all? 80i squared. And then what? I got to replace that I squared, don't I? I squared's what, y'all? It's negative 1. It's negative 1. 80 times negative 1 is negative 80. Could I check that? How could I check it? Almost every single one of you have it on your desk. Check it in your calculator. Why wouldn't you? If it has no variables, throw it in your Sadie can't have this side. Sorry, I was distracted. Oh, it is on. I don't know who. Did anybody from this side write that? From this side? From this class? It's on. You know she's going to write a rebuttal, don't you? Okay. Huh? Tucker? Oh. Don't do that. Not that Tucker. Other Tucker. The other Tucker. Are we going to show how many of you are going to show every single step that I just showed when you do your homework? All of this. Liars, you're not going to show all that. Yes, I am. Yes, I am. You're definitely going to now, aren't you? Because I told you weren't. Even if I were doing this problem, I wouldn't show that many steps. Okay? Can you just use the calculator? You know my answer to you is going to be no. You got to be able to do it on paper. Check it with your calculator. Now, when I'm at home, will I be at home standing over you doing homework? No. So I can't control that. But you'd be better off knowing how to do this by hand first and checking with your calculator. Okay? But when you take an SAT, what are you going to do? You're going to blow that calculator up. And that's what I want you to do. When you take the SOL, that's what I want you to do. But I hate those things. I hate them. Hate them. Questions at all? Facile or difficile? Muy facile, see? Yeah? How about this? Keep going. What would happen? Now, this is something new, so everybody's got to take some notes here. Oh, not new, a review from Friday. What if I had the square root of negative 25 raised to the 4th power? What are you going to do first? What are you going to do first? The negative, you're going to take care of the negative first? Well, be more specific. Somebody expound upon what Paul is saying. You can go ahead and simplify. Folks, what is the square root of negative 25? 5i. Can we work from the inside out? Yeah? So take 5i, and we're going to raise it to the what? 4th power. You got to know, folks, you got to know. We have a power raised to a power. What are these powers here with the 5 and the I? Right now, they're ones. Okay, bless you. I could say 5 to the 1 times 4 is 4. And I to the 1 times 4 is 4. Can I? I could do that. Could I also write this how many times? Can I also write that 4 times? You can write that out longhand. That's another way to do that problem. You don't have to, but just know that it's there for you to do. What is 5 to the 4th power? 625? And you know me. See, I'm right now in front of you going out of the 4th, out of the 4th, out of the 4th. Okay, so right off the top of my head, I'm thinking this right here. I squared, negative 1 is positive 1. I'm causing myself a lot of work by not knowing those 4, aren't I? But it works. It works. So I to the 4th is actually just plain old 1, yes? What's my answer? 625. Could I put that in my calculator to check it? Could I put it in there to begin? Sure, you can. Your calculator has to be in what mode, though? It has to be in A plus BI mode. Okay? Be aware of that. Right there, A plus BI mode. Comprende? So maybe I'll do it this way. Maybe if I know I1 and throw my negatives in the middle, then I'm going to know that this is I to the 1st, I to the 2nd, I to the third, I to the fourth. Yes? Yeah, it kind of does. Kind of does. What happened with, what comes before this? Just out of curiosity. What came before that? Let's see how many thinkers I have in here. What? Say it again, Catherine. 1. How would I get it, though? You're saying that before this, it would be a 1 up here? It is a pattern. But how would there be a 1 there? Boom! Tag team. Say it again. Anything raised to the 0 power is 1. Atta girl. Atta girl. Very good. Did I even get it? Yes, it's recorded. Yes. You got to know. I1. So this is, I just learned the pattern in front of y'all. I1, negatives in the middle. This is what I'm focusing on, that right there. What if I gave you something with, find I to the 25th power? Some of y'all just looked at me like, what? What? What if? How do you know? Oh, you know what I would do? 24 is a factor of 4, which would leave what? Y'all know I like to do what? When I deal with fractions, especially when I'm dividing fractions, do I do the whole bracket thing? Y'all know how, I think this is right. Do I do that? Do I do that? No, what do I always go? I go old school. Oh, go old school. Watch this right here. Oh, and I just even have to write that on the board. Go old school for just a minute. Go back. I like to go back to what I already know. Our magic number is what, Q? 4. That's our magic number. Because we know a pattern that's 4 I's, don't we? What am I doing? I'm taking my magic number 4, and I'm going old school, and I'm dividing 4 into what number? Into my exponent. How many times is 4 going to 25? 6. That number's not important to me. What number's going to be important to me, Q? My remainder. What's 6 times 4? 24. What's my remainder? 1. This is my important number because it becomes the exponent of my answer. What's I to the first power? I. So I to the 25th power is I. Q said it beautifully. He said it beautifully. 4 is a factor of 24, and that leaves 1. He said it so way better than I did. And he's right. You're a mathematical genius. And I said what? Go old school. Look, the remainder. It's the remainder. That's the important number to us. So I to the 25th is actually I to the first, which is I. Could I go my way? I squared times I squared times I squared times I squared times I squared. How many times? 12 times. And how many would be left over? I could do it that way, and it would work, but it would take forever. How about this one? I would write this right here on every paper I get. And I'm going to have to actually do that on the next page. Not really. I probably will. Here's another one. I guess this is example 2 of those. How about this? How about I to the 100 power? Some of you are going to be able to look at this and go, boom, got the answer. I can't do that. I can't do it. I just can't. I'm going to go old school. What am I going to do? 4 divides into what? 100. Because I know the pattern of 4 I's. 1, 2, 3, 4. That's my highest. That's where the 4 comes from, okay? 4 goes into 100 how many times? 25 times. Do I care about that? Nope. 25 times 4 is 100. What's my remainder? 0, which becomes the remainder of my answer. And what is anything raised to the 0 power? 1. How about them apples? Fossil or difficile? I know I'm showing you a different way than probably Ms. Harrell or Mr. Gammons would show you, and that's cool because we all get to the same answer a different way. But this is what my little brain has to think. Okay? That's what I have to think. How about this one? I'm going to give you 2 more. I to the 23rd, and then I want you to simplify I to the 37 power. Go. Record this. All right, so Dustin, you probably figured this out at home, you lucky dog. Y'all, look at this. Hello, calculator, our friend. Why is Miss Perry making us do all this mean stuff? Because Miss Perry is not a calculator ninja, okay? Don't be hating. I just seriously don't understand. I hate the calculator. Let's say I wanted to find the square root of negative 25. And I want to raise that to the 4th power, okay? You got to be sure that you put parentheses around the square root, folks. Shamalama ding dong. I'm going to because I like parentheses. I don't know the answer to that, Christian. Negative 25. I think you, look, shut the front door. I hate calculators. Autumn, don't make fun. I saw you. I would use parentheses. Now, check this out. Go to the I to the whatever. Go to the I to the 25th. Do y'all see the decimal button at the bottom? You should have either a blue or a yellow I. Let's see what I to the 25th power is. Oh, look. Something and then a plus I. What's the answer, y'all? Positive I. I hate these things. Let's do the next one. I to the 100 power. Shut up. 1? Really? I hate calculators. I really don't like them at all, if you haven't figured that out. But do you see what we're looking for? Sometimes it's going to work out nicely. And oh, look, negative I. Why didn't... Well, let's figure out what I to the 24th is. A plain old I think. But if I went old school, I would know. So let's just see what it is, old school. To the 24th would be 6. 0 to the 0 would be your power. So the answer is the 1. See, that's why you have to know it on paper before, because you don't know what you're looking for. It's 1. It's not I. Good point. Dante, which one is this? 5? You said I to the 24th, right? And that's, our calculator's going to give us this thing. Well, you don't know what to look at. The answer's there, but you don't know what part of it. I know because I know it on paper. Ha ha. 6, remainder 0. I to the 0 power is 1. You just got to know, I guess. It's going to be the 1 in the front. But the 100 gave us 1. It sure did. I don't know why.
Isn't it just whatever, like, if you have, like, I raised to the 7th gives you negative 3e minus negative 13 minus I,
Minus I is negative I.
I is the negative one. That does, like, with 34. That doesn't have anything.
Okay. I don't like the calculator. I will continue my old school way because my way works. You guys understand a calculator more than I do. I hate them. You still should have to know why. Thank you for the solve this equation. Bless you. X squared plus 7 equals 0. Just for kicks. What are we going to do there? How do you solve? Before then, what will I do? Minus 7. Minus 7, I get I squared is equal to negative 7. What do I do now? Square root of both sides. And then, Dylan, what am I going to do? Take out the I. And don't forget, how many answers am I going to have? 2 answers plus minus, right? I root 7. If you had to do that on paper, that's the way you have to do that, okay? Yes? Because if, remember, think about it this way. 49 is a perfect square, right? Let's go backwards. Let's start here. What are the 2 numbers that I can multiply together to themselves that will give me 49? Positive 7 times positive 7 and negative 7 and negative 7. So the answer can either be positive 7 or negative 7. Same thing here. That's why we have to take into account the 2 answers. This becomes very important to you in trig, the 2 solutions, the plus minus. Okay? Let's do one more.
So whenever we get, like, instead of going for plus minus, right here.
Absolutely. Yes. If your solutions, if you know the first example we did today, we solved the first one by factoring and we had negative 5 and 5 in our solution set. Instead of writing 2 5s, just write plus minus 5 in the solution set and you're good to go. That's all you have to do. Question? Okay. Here we go. One more. Is this example 7? What about this one, folks? 2x squared plus 72 equals 0. Solve that for me. What do I do to start solving? Subtract 72. 2x squared is equal to negative 72. What do I do then, folks? Divide both sides by 2. X squared is equal to negative 36. What do I do then, folks? Square root of both sides. X is equal to, you tell me, plus or minus 6i. How many of you had that as your answer? Rock on. What up? What up? No, whenever we take the square root of a number, it's always going to be plus minus. Okay? Here we go. Review. Okay? We're going to review. I want you to take a look at the clock. Yep. Okay. What? For real? No way. A lot of this is calculator stuff, folks, okay? And I'll be honest, I got to wrap my head around what we have to do tomorrow, so you're going to work. My hope for you is that you don't have homework tonight. Bless you. Okay? I don't want you to have homework. I don't want homework. I've got homework, but tough patootie. Look at page 57, if you will. Oh, yeah, we ain't done. I just pulled your leg, didn't mean to. This was a joke, and it was a cruel joke. Sorry. Nothing. We're still simplifying. It is. Nope. You are taking notes. You are still taking notes. I faked you out and I didn't mean to. I didn't do it on purpose. What up? What up? I really didn't do it on purpose. I misspoke. Politicians do it all the time. I just misspoke. Okay? Here we go. Add and subtract and multiply and divide in like terms. Folks, if I wanted you to simplify this. The quantity 8 plus 7i plus negative 12 plus negative, whatever it is. Negative 12 plus 11i. See, I totally want to see if I can put this in the calculator. Now that I just said that, you're going to want to do that too. Because if our calculators are in A plus BI mode, shut the door. Gosh, look at that. That's so stinky. Of course, I want to show, I want to show all my steps. 8 plus negative 12 is negative 4 plus. How many of you punched in your calculator and got negative 4 plus 18i? Really? That's the way I feel about the calculator. This is the way you feel about the calculator. This is me. This is y'all. I just literally wrote y'all on the board. Yes, I did. Because I'm very professional and very technically savvy. Y'all, spell it. Learn how to spell that word. We say it, you need to know how to say it. Spell it. Spell it. I was thinking spray it. Say it, but don't. Stop making fun of your teacher. Here we go. Look at another one. Because I know you're going to put it in your calculator. But I can do it before you can. Boom! I didn't use a calculator. In my head. Are you impressed? Because you should be. Thank you. God, I hope it's right. Yes. See, it takes longer for you to put that stinking mess in a calculator. Yeah. That's all you would do. This is what I did. Well, I totally lost the parentheses, first of all. And then everything turns into its opposite. And I just want to say again, I did this faster than you in your calculator. I know. You don't need the calculator. The calculator is the devil. It's the devil. How many of you put it in your calculator, though, seriously, and you got negative 10 plus 6i? I know you're going to. I know you're going to. Some of you are like, yep, every single time. Questions at all? Facile or difficile? Super, super grande facile? I don't know the word for super. Super big, easy? Mucho, super grande, mucho grande? Facile? Humongous. What's the word for humongous? Here we go. What? It's not. And I'm not going to say it, and you can't make me. Here we go. How about this one? Just for kicks. 2 times -7 plus 4i minus 4 times 3 minus 2i. I bet I could still do this before you. Listen to you clicking. Ha 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 ha. High five in the air. Yes, attaboy. Attagirl. Calculator or noggin? Did you use your calculator? TB, did you use your calculator? Attaboy. Ted's just grinning. I'm using mine. Just wanted to answer. Didn't that time. It's sometimes way easier just to do it in your head. How many of you got this? Hey, aren't we using the same concept that we used back in Algebra 1? Now it's just got a funny looking variable. That's all we're doing, folks. We're using, it is a funny looking variable. Okay. Right. Yeah. Ah. Here we go. Here's another one. Here's another one. Will it work for multiplication? 2 plus 3i times the quantity. 3 plus 4i. It's the same difference. Look, I know y'all are waiting for me to turn my back so you can blow that calculator up. Huh? It does give you the right answer. Calculator. Calculadora. What did I do? All right, now check this out. What did I do? You FOIL it out, folks. All right? 2 times 3 is 6. 2 times 4i is 8i. 3i times 3 is 9i. 3i times 4i is 12i squared, correct? And then what is I squared? -1. I combined my I terms, my like variables. So I got 6 plus 17i minus 12. How'd I get to minus 12? 12 times -1. And then I combined 6 and -12 to get -6 plus 17i. But, Lexi, does it work in a calculator? Absolutely. Yes. Why am I able to multiply? No, because it's multiplication. There is never any time, you will always be able to multiply 2 times 4i, always. But when you're adding, you can't, because now we're adding, okay? Same thing as if this were 2 times 4x. What would you get? 8x, 8i. Okay? Yes, ma'am. This I? Why did we have to have an exponent?
Yeah, like a while ago, well, 10 exponent of 1.
It does. But what's I to the first? What's 3 to the first power? 3. What's 2 to the first power? Stop talking. 2. So what's I to the first power? I. Anything to the first power is itself. So I to the first power is I. So that I stays. You see?
Yeah, I got it.
Okay. Here's another one. Just one good way to finish this out. -5 plus 6i quantity squared. You'll probably beat me this time. hit me that time, didn't you, Anna? What happens when you get home and you don't have batteries to your calculator? Oh, that's when y'all will come the next morning and go, Miss Perry, my batteries, they went dead and I couldn't do my homework. And I'm going to go, you can, or you can use your cell phone. Ah. My cell phone isn't that high tech either, Ted. I'm okay with that, though. Hey, what are you thinking? Phi-sil or DP-sil? How many of you are doing this on paper? You are actually doing this in your head. Is it easy? It's easy. How many of you blowing that calculator up? Be honest. Claim it. Is it easy? It's still easy. Okay? Either way, this is easy stuff. Do you agree? Don't you like complex numbers? They're not very complex, are they? All right. Now we're done. Pardon me? We do need to divide, don't we? Thanks. We do need to divide. I know. I'm just full of tricks today. What if? I have no idea what this is going to end up being because I'm totally making this up. You're welcome. Y'all just stood up in your calculator, didn't you? All right, now, let me just do some thinking. Did you put it in your calculator? Okay, and, well, let me put it in my calculator. Did you put parentheses around the 4 minus 3i divided by parentheses 2i? And I get negative 1.5 minus 2i. That's what I got. Is that what you guys got? Wonder if I could math frac that. Oh, yeah. Okay. Ooh, y'all are making me think on my feet. I would separate it. Okay. And then, because, and this is something that will benefit you in trig, anytime you have a binomial over a monomial, I can break that down into the first part of the binomial over the denominator minus the second part of the top over the bottom, okay? 4 over 2, of course, is 2i, which is there, because it's thinking that the I should be there, minus 3 halves, and they cancel here. So it is the same thing. Yeah, it is. Hold up. 4i over 2i squared, which is 4i over negative 2, which is negative 2i. Boom, that's it right there. All right, how'd I get the 2i squared? All right, here we go. Let me come back here. Remember when we had, let's say we had 1 over root 3. What did we have to do? Can you have a radical in the denominator? No. So we had to rationalize. And how do you rationalize? You multiply by root 3 over root 3, which is actually just what? It's actually just, we're multiplying by 1. And we would get root 3 over plain old 3. Do you guys remember that? Okay? We cannot have stars. Put this in your notes. Oh, just erase. You cannot have I in the denominator. which means rationalize. Rationalize. Which is the same thing we did with the radicals, okay? All right. That means this piece here, folks, those i's, you guys understand why those i's cancel, don't you? If it were 3x over 2x, wouldn't the x's cancel? Yeah, same reason, same reasoning. But you're probably going to want to come over to the side and take care of 4 over 2i. We have to rationalize and get rid of that I in the denominator. I don't even know if this is actually on the SOL, but at least we're going over it and you'll know it for future reference. Multiply by 1 in the form of I over I. And now let's multiply. 4 times I is 4i. 2i times I is 2i squared, correct? Bells and whistles. What's wrong? That was kind of a cuckoo clock. Sorry. What's I squared? -1. So we're going to say 4i over 2 times -1, which is 4i over -2. And then, folks, what's 4i divided by -2? -2i. So, come back over here. We just rationalized 4 over 2i. Put you a star here so you'll know what you did. What did we get? 2i? -2i. And folks, isn't that what was in your calculator anyway? But I think it was rewritten, yeah, except it had -3/2 first. So our answer is -2i minus 3/2, or -3/2 minus 2i. That's acceptable because of what property? If order changes, what property? Which is commutative property of addition or subtraction, which makes it acceptable. I probably would blow this up in my calculator myself. That's a lot of tedious work that, you know, is it necessary, is it not? Yes? Thinking? One more. You know where I'm going. It's going to look just like number 16 in your workbook, page 57. So you're processing. What are we going to multiply by? The conjugate. We're going to multiply by the conjugate. Got it? Yeah. One that looks just like number 16 on page 57. Oh, mercy me. Let's go 2i over 3 plus 5i. All right, someone has already said, folks, if we think of this as a radical, we know we can't have radicals or imaginary numbers in the denominator. What are we going to multiply by? Somebody say it loud. The conjugate. The conjugate is going to be what? 3 minus 5i, which is actually just a souped up version of what? Of 1. All right, and we're going to distribute on top. And we're going to FOIL on the bottom. All right? Don't be fooled. We're doing the same thing we always do. What's 2i? Let me see. Times 3. 6i. What's 2i times -5i? Let's take it every step. -10i squared. We know that's going to change. We know it's going to change. And then at the bottom, we're going to FOIL it out. We know that it ends up being a difference of squares, doesn't it? So we only have to multiply the first terms. 3 times 3 is 9. 5i times 5i is 25i squared. Positive times a negative is a negative. And now we're going to simplify, okay? Now we're going to simplify. And we're going to have 6i minus 10 times negative 1. 9 minus 25 times negative 1. Because I'm taking into account my I squared, which is negative 1. I'm going to simplify next. Negative 10 times negative 1 is positive 10 plus 10. What's negative 25 times negative 1? Positive 25. We'll simplify again. 6i plus 10 over 34. Factor out of G. We got to reduce this thing. Okay? So I'm going to take out a GCF because I've got to reduce. Make yourself a note. To reduce, take out GCF and cancel. So my GCF of the numerator is 2, which is 2 times the quantity 3i plus 5 over 34. And now I'm going to cancel 2 goes into 2 one time, 2 goes into 34 17 times. So 3i plus 5 over 17. If you put that in your calculator, you are going to have one nasty mess. And I'm sure you can math frac it. And it might give you the same. It might give you 3i over 17 plus 5 over 17. The same thing. It's the same thing. It gives you the same answer. There may be a reason why I didn't have this in my original notes, because this may be a little too much for Algebra 2. I don't know. I've not seen it on a previous SOL test, but it doesn't mean it's not going to be there this time. Okay? And look at the workbook page, y'all. Look at all those problems on page 57. Look at 1 through 22. How many problems are we dividing out of 22 problems? Just 2. Okay? So I'm giving you enough information just to make you dangerous. All righty? I've just given you just a taste of what could be next. 3i plus 5 over 17 is our final answer for that. Let's look at page, I'm not playing jokes on you now, workbook, page 57. Yeah, y'all. I was thinking y'all and guys at the same time. Guys, y'all. I want you to do 1 through 22. Please use your time wisely. I'm telling you, I get fussed at every time I give you homework. So when you see my son, tell him thank you. So he lets me have it for giving y'all homework. Sorry. You got to do it. You got to. Use your time wisely and burn off half of that right now, okay? 1 through 22. I have to do it too. At the beginning, the first 3 problems, that's a review of radicals. That's just what we did, 2 weeks ago? Okay?